So now that we've talked a little bit about cost functions, let's move to a new kind of function called the demand function. Now, this function may be new to some people, especially if business was not your major as an undergraduate. And this is actually one of the most challenging ideas for students to process and remember and use throughout the quarter. So I would encourage you to carefully come back to this over and over again, make notes to yourself, because this does tend to be an idea that students need time to process and to master. So here's the idea. The demand function for an item that you're going to sell, let's say, or produce, gives you a relationship between two important quantities. The first one is the price, which we'll call P, that you can charge per item, or that you charge per item. So we're setting some price for some item that we anticipate selling out in the market. That is related to the quantity, which we call Q, of those items that we can sell at that price. And that's really important. What we have in this situation then is a bunch of pairs. P goes with Q. So at a price P of, let's say, $10, we can expect to sell 50 items. If we increase the cost, then the assumption that we make is that because it's more expensive, the quantity in demand will be lower. So there's always this relationship between these two variables. Price goes with quantity, quantity goes with price. So we'll actually think of these as pairs, ordered pairs or points. Q is normally on the horizontal axis, P is normally on the vertical axis, so we can write them like X comma Y, but instead we're using Q comma P. So that's the relationship we're talking about when we speak of a demand function. It's a function that relates two variables. Q is the independent variable in this situation, quantity and demand. P is the price. So let's take a look at what this means in practice. So let's take a look at a particular demand function. The demand function that we're given here is that d of q is equal to negative 3q plus 250. So first, let's notice that there is a relationship here given, like we said on the last slide, between the price P on the left and the quantity and demand on the right. So we say that P is a function of Q. So in other words, the price that we can charge per item is related to the quantity in demand at that price. And that's reflected on the graph that you see here below. The vertical axis is price on the vertical axis and Q, quantity and demand, on the horizontal axis. This is a typical shape for a demand curve. It's usually downward sloping, and you'll notice that as the quantity in demand goes up, as you assume that you're going to sell more items, the price per item goes down. The more you sell, the less you sell per item. The fewer that you sell, the more expensive the item. That's a basic assumption we're making here in this course. It has to do with monopolies. But we won't go into much detail there. I'll leave that theory to your other economics courses. So here you see this demand function. The slope is negative 3. That's the downward slope. The y-intercept is at 250. You can see that on the vertical axis. And so the problem that we're going to explore here is, if we sell 40 units, at what price can we expect to sell them? So if 40 units are in demand, what's the price that we can sell each of those 40 units at? So the way we set this equation up would be to say, okay, we're given a quantity value. The Q value is 40. And so we are going to substitute that into the equation. We're going to evaluate the equation, the demand equation, or the demand function, when Q is 40. So we say that d of 40 is equal to negative 3 times Q, but Q is 40 here. So negative 3 times 40 plus 250, and then we do the arithmetic. We get negative 120 plus 250 on the right, and then when we add these two numbers, we get 130. Now remember, This 130 is D evaluated at 40, and D of Q, D of 40, is a price. So the way we would interpret this is we would say that at a price of $130, 40 items are in demand at that price. Or when 40 items are in demand, you can expect to sell them for $130 each. The ways you can think about that. If you look at the graph, what we're basically saying is that if you locate the value of Q along the horizontal axis, go up to the demand line, locate that point, and then go over to the vertical axis, which is price, you're going to get $130. As you can see, that's reflected there on the picture. Each point on the demand line represents a different combination of quantity and demand and price at that quantity. So, for example, if we were to look at a different price and a different quantity combination, let's say this one where Q is equal to 50, you'll see that because we're selling more, in order to sell more, we're going to have to lower the price. In this case, you can see when the quantity in demand is 50, the price drops to $100 per item. So every single point along this curve is a combination of price and quantity. And again, we're back to that hypothetical situation. If we're going to create some new product that we want to sell out in the market, the price we can charge for it, assuming we have a monopoly, is going to depend on the quantity and demand. And we can also think of it as if we want to set a specific quantity and demand or establish a particular quantity and demand, then there's going to be a price per item associated with that. So again, we're back to that very interesting relationship between price per item and quantity and demand. That is always given to you with the demand relationship, the demand function. This is something we're going to come back to over and over in this quarter. So pay attention to it, and if you have questions, make sure you post them to the forums. Let's take a look at a different kind of question involving a demand curve. We're going to use the same demand curve that we just used in the previous slide. But now the question is, how many units can we expect to sell if the price is set at $55 per item? So now we're no longer being given a quantity Q, so we can't just plug that into the function. We're now being given a price. So remember, the price is the left side demand function as we have it written here. So in order to answer this question, we're going to start by letting P equal 55 and then go from there. So the steps are laid out here. Let's talk about them one at a time. First thing we notice is that we're substituting a value of 55 for P, not for Q. So that gives me the left side of the equation. The right side of the equation has the variable Q that we are trying to solve for. So we're basically going to do a little bit of algebra. To isolate the negative 3Q term all by itself on the right, we're going to subtract 250 from each side of the equation. When we do that, the left side becomes negative 195, the right side becomes negative 3Q. And then to solve for Q, we would divide both sides by negative 3. That turns everything back to positives, as we would hope, and that gives me a quantity of 65. So, what does that mean? How would I interpret this particular value of Q? This value of Q, 65, tells us that if the price is set at $55, we can expect the quantity in demand at that price to be 65 items. In other words, if the price is set at $55, there are 65 people willing to buy it at that price.